Hello students, our today's experiment is to determine the molecular weight of a non-volatile solute by Rast method. For this, the apparatus required are melting point apparatus, thermometer, watch glass, etc. And the chemicals required are camphor, ether and the given unknown solute. The principle behind this experiment is that when a non-volatile solute is dissolved in a solvent, the melting point of that solvent is lower. The total decrease in the melting point, which is known as the depression in the melting point or the freezing point, is related to the molecular weight of the solute by the formula M is equal to 1000 kW upon delta T into capital W. This capital M is the molecular weight of the solute, K is the molar depression constant, W is the weight of the solute taken. Here we have taken 0.1 gram. Delta T is the depression in freezing point that we are going to determine. It is either the freezing point or the melting point. And the capital W is the weight of the solvent taken, which is the camphor here, and we have taken 1 gram of camphor. For weighing purposes, we are using this electronic balance for weighing the unknown solute, the solvent. For this, we have taken an empty watch glass. The weight of this watch glass is 18.76 gram, but we can tear this so that we will get 0. Then we will weigh 0.1 gram of the unknown solute. So here we have taken this unknown solute, which is 0.1 gram, and the solvent, pure solvent that we have taken is camphor, and we have weighed 1 gram of this camphor. Now we will mix the unknown solute and the solvent, and to dissolve these two solids, we are going to add petroleum ether to this mixture. So we will add few drops of petroleum ether, which should be just excess of the two solids. Now we are going to mix the two. As the two solids dissolve in this petroleum ether, the ether is going to evaporate, and then we will get the mixture of the two solids. Now we have dissolved the unknown solute with the camphor in the ether, and finally we are going to get a solid mixture like this, where the ether is completely evaporated and we are getting a dry solid mixture of the unknown solute and camphor.
Now since we have to take out the melting point, this is the way how you seal the capillary tube. You take a small piece and then you just fuse it by small rotation, slight rotation intermittently, and this is the way you seal the one end of the capillary tube. Capillary is sealed one end. Now you fill up this with the prepared solution of camphor and the given solute. Okay, first you have to find out the melting point of the pure solvent, that is camphor.
Now the next part of this experiment is determination of melting point of first the pure solvent and then the mixture. So for this we have taken this melting point apparatus. Here we have tied this the capillary tube containing the pure solvent, that is camphor, and we are determining the melting point of this pure solvent. The camphor has completely melted and the melting point of pure solvent comes out to be 174 degrees Celsius. So after determining the melting point of pure camphor, we are going to determine the melting point of the solution of camphor and the given solute. So this is the mixture of camphor and the solute after evaporation of ether. So we have taken again in a capillary tube this mixture, and we are determining the melting point of the mixture using the melting point apparatus. And finally, we obtained the melting point of this mixture to be 143 degrees Celsius.